Hey guys, videos in this playlist are dedicated to the big level 7, 8 and 9, 4, 5 and 6 mark questions that we find towards the back of exam papers. So what I aim to do is show you how to first of all work out what a question is asking us to do, then how to plan our attack, and then carrying out the attack in hopefully easy to follow, step-by-step solutions. So, if you're finding these videos useful, don't forget to give us a cheeky thumbs up, support the channel by hitting subscribe, and if you find any questions that you think deserve a spot in this playlist, you can send them to me on Facebook or Twitter. Send me a cheeky little message, and if I think they belong here, I will do my best to put them in a video. Okay, in this episode we are looking at a 5-mark simultaneous equation question, and it's this guy here. So what we've got going on here, this top equation is a quadratic. It's quadratic because we've got powers of 2. It's actually the equation of a circle centered at the origin with radius 5. So the top guy is a quadratic and this bottom guy is a linear equation. So the technique we use to solve these guys is called substitution. So that's what we're going to be doing with this example. So if this is tricky or new to you at all, do check out my playlist on simultaneous equations, where this technique has its very own video with about 5 examples in it. So, for substitution, the first thing we need to do, if we haven't got it already, we need to play around with the linear equation to get one letter on its own in terms of the other letter. So at the moment we've got our y and x terms on the same side, so we don't want that. So what we're going to do, we're going to add 3x to both sides, and that's going to leave us with y equals 3x plus 13. So that little guy there, that's our first step, and this is where this technique gets its name from, substitution. We now substitute that into the quadratic equation up above. So we no longer think of y as y, we now think of y as 3x plus 13. Okay, so if we make our substitution, then our quadratic is now going to look like this. X squared plus 3x add 13 all squared is equal to 25. So that's the substitution step. Next, we expand the bracket. So check that you get the same as me here. So if we expand the bracket, we've still got this x squared at the start. Then we're going to get 9x squared. We're going to get 2 lots of 39x, which is 78x. And then we're also going to get 13 squared, which is 169. So, that's our left hand side. And then on the right, we've still got is equal to 25. Okay, next step, let's simplify. On the left hand side, there's not really much we can do. We can just combine the x squared terms. So x squared add 9x squared, it's going to give us 10x squared plus 78x plus 169, and that's all equal to 25. So now what we've got a normal, if there is such a thing, a normal quadratic equation that we now want to solve. So, to be able to solve quadratics, we need everything on the same side together and a nice big fat 0 on the other side. So what we want to do now is take away this 25. So if we do that, we're going to get left with 10x squared at 78x, and then 169, take away 25 is 144. And that's now equal to 0. Okay, so the ideal way to solve a quadratic, if we can, is to factorise. So at this point, we could factorise, but first of all, there's a little check that we should do at this point to see if we can make life a little bit simpler too. And that check is to see if we've got any common factors running through the quadratic. And here we do. We have a common factor of 2 on all 3 terms. So now we're going to divide through by 2. And that's going to leave us with 5x squared plus 39x plus 72. And that is all equal to 0. So our job now is to try and factorise this quadratic. So it is factorisable. If it looks completely horrible to you, you can of course just try and use the quadratic formula. The quadratic formula, as long as the quadratic can be solved, the quadratic formula will always work. This though is actually from a non-calculator paper, and I always try and avoid formulas if I don't have a calculator handy. Personal preference. So I'm going to take you through my preferred method to factorise a quadratic like this. Now this method always works as long as the quadratic is factorisable. If you've never seen it before, search out my video called Factorising Harder Quadratics. So the first thing we do, we multiply the coefficient of the x squared term by the number at the end. So here, 5 times 72 is 360. Now what we need is 2 numbers that multiply together to give us 360 and add together to give us the coefficient of x in the middle. So if we went through our list of factor pairs of 360, so there's quite a few. So for example, we'd have 1 and 360. That would add together to 361. If we carried on going through, we would get to 15 and 24. So 15 times 24 is 360, and 15 add 24 is 39. So I honestly think we've reached the point here as to why this question is worth 5 marks. This is not a nice quadratic to factorise and then solve. So what we now do, now we've got these 2 numbers, we open 2 sets of brackets, and each bracket has the same number of x in as the quadratic has x squareds. So the quadratic has 5x squareds, so we open 2 brackets, each with a 5x inside them, like that, and we still have r equals 0. So what we do now, we plonk in each of these 2 numbers that we've got, so 15 and 24, inside of each bracket. So we're going to have 5x plus 15 times 5x plus 24. Now that's obviously not right at the moment because, well, first of all, if we did 5x times 5x, we would get 25x squared and not 5x squared as we want. So the final step to factorising our quadratic is inside of either bracket that contains a common factor, we divide it away. So in this first bracket, 5x plus 15, there is a common factor of 5, so we divide that away, which leaves us with x plus 3 times 5x plus 24, and that is equal to 0. So that is our quadratic factorised. If you want to check that it's right, try expanding that back out, and you should get 5x squared at 39x at 72 is equal to 0. So if you've never seen that method before, it's not really a great question for it to be your first encounter, because that is a truly horrific quadratic where we had to think of multiples of 360. Not nice. Okay, but the good news is we have now factorised our quadratic, and from this we can now get our two x values. Okay, so how do we get our two values? Well, hopefully we're used to solving quadratics by factorising. This left hand bracket, x plus 3, that tells us x is equal to minus 3. What about this second bracket though? Well, remember what we are finding the value of x that makes the bracket equal to 0. So that's why in the first one, our solution is x equals minus 3. Minus 3 plus 3 is indeed 0. So what we do in the second bracket, it's not quite so simple. We have a little equation that we need to solve. So we set 5x plus 24 equal to 0. And then we solve it. So 5x plus 24 is equal to 0. If we take away the 24, we get 5x is equal to minus 24. And then finally, if we divide through by 5, we get x is minus 24 over 5, which is equal to minus 4.8. So the good news is at this point we've done most of the work. The bad news is we've only got half the answer, but it's so simple to now finish it off and get the other part of the answer. So I'm going to clear this up and take us back up to the top to finish this guy off. Okay, then the last little bit we need to do is find the two y coordinates. So what we've got so far, we've got our two x values, minus 3 and minus 4.8. To get our two y values, we substitute each x value into our linear equation that tells us what y is. So y equals 3x plus 13. So we do it separately. So let's first of all substitute x equals minus 3 in. So when x equals minus 3, y is equal to 3 times minus 3 minus 9 plus 13. That gives us 4. So when x is minus 3, y is positive 4, or when x is minus 4.8, y is equal to 3 times minus 4.8, which is minus 14.4. Add 13. And that is equal to minus 1.4. So there are the 4 parts of our answer. When x is minus 3, y is positive 4. When x is minus 4.8, y is minus 1.4. Okay, jobs are good. Hope you found it useful, guys. Until next time, TTFN.